Thank you so much, Olivier. And I would just want to say it's been a pleasure to have been asked to present and to engage in a dialogue with all of you. You really represent the epitome of complexity in evaluation, so it's challenging and so forth. As Olivier said, that I am a methodologist, and what I like to do is to really talk about a number of different evaluation tools, and qualitative comparative analysis is one of those tools. It doesn't really serve us well to argue the benefits of qualitative versus quantitative and vice versa, randomization versus quasi-experimental and descriptive studies. What we need to do is to use the right tools for the right questions, and keeping in mind that we also have feasibility and practicability issues as well. So I'm going to proceed and actually talk a little bit about bringing rigor to qualitative data. In the past, qualitative data has been characterized as opinion, subjective. You ask a lot of people questions and then you sort of mull it over in your head and come up with the results. And the reality is that qualitative data is anything other than that. QCA actually allows us to bring some methodological quantitative rigor to what is essentially qualitative data. And so we're going to, is this?
It's this one.
This one, okay. What we're going to talk about is development. And in the development world, we have what I call complex adaptive systems. My colleague, Michael Patton, has written a book on developmental evaluation, which is not evaluation that only takes place in the developing world, but it essentially means that things are in constant state of flux. Things change. Most of our evaluation is nonlinear. It's very dynamic. So if we're looking at health, if we're looking at peacekeeping, if we're looking at crime and corruption, we're looking at that embedded in other systems, economic systems, political systems, all of which have an impact in terms of the outcomes that we're trying to assess. So outcomes are better understood through a very dynamic kind of process. Individuals change relative to the context that they are in. Chance meetings can change an individual. Countries and country sectors that have experience with bilateral and multilateral projects have a rich history, and some of whom can take better advantage of the opportunities that are presented to them, as opposed to countries who have no history and so forth. So when we're talking about complex adaptive systems, we're looking at the interconnections between individuals and the systems in which they inhabit. So we're talking about beneficiaries who are embedded into communities, who are embedded into villages, country sectors that are influenced by both political and economic national history. So we're moving away from predictability. Everyone would like us to say, what is, the likelihood of an outcome of a specific magnitude. But in complex adaptive systems, what we're looking at is not predictability at a detailed level, but predictability overall. We're looking for the emergence of patterns. And this really fits very nicely in qualitative comparative analysis, because in qualitative comparative analysis, you'll see that we're looking at patterns rather than looking at an outcome and the additive properties of all of those influences. So it's broad focus, and order is natural. It's not really imposed by the program or the intervention. We have what we call causal density and intervention complexity, and you know this even better than I. The extent of the complexity is really influenced by the number of person-to-person interactions, the diversity of the frontline implementation, and the preferences. We know that we may have a wonderful logic model or theory of change that is developed at headquarters, but when it gets rolled out on the ground, it may look markedly different, because it will be influenced by village and community sectors and so forth. We have distracting conditions. Elections that come up can be a distracting condition. Change in the stability of a country can be a distracting condition if in fact you're implementing a health program or an education program. So we have a number of solutions that are possible, and many of those solutions are adaptive and they are modifications of the original intent. And we're looking for innovation and adaptability, and we want to be able to track that, because if we don't track that, then the conclusions that we reach won't allow us to have a comprehensive understanding of what happened. We have implementation capacity, and we're looking at the level of fidelity. And when we're talking about fidelity, it's the adherence, the integrity, the quality of the program intervention. And oftentimes when we're doing evaluation, we seldom pay attention to the level of fidelity of our programs and interventions. Not because we don't think it's important, but because we don't always have the resources or the time to do that. So we're looking at expectations. Whoops, let's go back. We're looking at some expectations, and the slides are a little cluttered because they were supposed to come up one by one, but apparently in the software you're seeing the entire slide. Our expectations, we're talking about potential impact, and our potential impact is always constrained by what I call time to expectancy. So our time to expectancy, unfortunately, is really constrained by the period of funding. So if we have a 5-year project, we expect to see an outcome in 5 years. If it's a 3-year project, it's 3 years. And oftentimes we don't pay enough attention in terms of whether we should expect to see an outcome in that time interval. So I always encourage evaluators to look at intermediate outcomes, so that if by chance we don't achieve the outcome that is desired at the end of the funding period, we can let the donors know that we're on a pathway that would most likely lead to the achievement of that outcome, but we just haven't had sufficient time for that to take place. In terms of, whoops, let's back here. In terms of an analytic approach, I want to really introduce Qualitative Comparative Analysis, better known as QCA. QCA has been around for quite some time. The biggest proponent is Ragin, R-A-G-I-N, and I will provide Laura with a list of references and other materials that she can disseminate to the participants on this webinar as well. QCA started in political science and sociology, and so it hasn't really seeped into other disciplines. But now we're seeing QCA studies being done in economic venues, health venues, education venues, and so forth. And it is theory-based. So Ragin would argue that QCA is very strongly theory-based. But the reality is that so are all of our other evaluations. We never go into the evaluation environment without having a hypothesis and some attention to program impact pathways. So we're looking at a theory-based. It's a qualitative approach, and it's an analytic technique that takes our qualitatively coded data and uses a Boolean kind of logic. So it moves away from traditional statistics, which are probabilistic. So when we're talking about, statistics, we often associate it with a probability value of 0.05 or smaller, and that's talking about how confident we feel that this is likely to happen. With QCA, what we're talking about is what's the logic of this happening in this way. QCA allows us to look at different paths. So if you're looking at program impact pathways, you would be looking at different configurations of important independent variables that would likely influence the outcome. So you would be taking a complex adaptive systems approach and saying it's not a one-size-fits-all. It's not an additive model. In some cases, it may be A plus B equals the outcome. In other cases, it may be A plus B plus C equals the outcome. In another case, it may be A plus B plus X equals the outcome. So if you look at those three hypothetical configurations, What is the emerging pattern in all of those three? Different pathways, but A and B are always present. And we're going to talk more in depth about that. So cases are sorted out in terms of outcome conditions, and then we look at the pathways that are associated with achieving those outcomes. But we're also looking at the pathways that are associated, oops, it moved by itself. It is moving by itself. Okay. The pathways that are taken to achieve that outcome are not the same, but they are likely to yield emerging patterns. So if you're doing an evaluation across a number of country sectors or across a number of countries, you will likely see patterns that are shared. Essentially, it takes a cluster analysis to look at what's the consistency of those emerging patterns. And we're going to play this out. So we're looking at consistency. Thank you. In QCA, just as is the case in most other evaluation approaches, we have a lot of very specific vocabulary. And this is also the case in QCA. We have necessity, consistency, and sufficiency. And we're going to go through these definitions with a little bit of detail. What we're talking about is aspects of cases co-occur. So you'll see a number of conditions that we believe, as part of our theory of change, that are related and influence the outcome that's desired. And what we're saying, it's not deterministic, but we have a logical framework so that if these things are present, it is logically assumed that we will inch our way to the outcome that's desired. It's not deterministic in the way that, for example, hand sanitizer is thought to be related to lowering the probability of infection. But people still get colds independent of how often they use hand sanitizer. So hand sanitizer in and of itself is not deterministic in terms of the absence of infection. It is a condition that supports the absence of infection. We have necessity, and these are conditions that are almost always present if the outcome occurs, but it does not directly produce the outcome. So for example, microfinancing programs typically lead to community economic development. But sometimes we know that microfinancing projects are handled inappropriately. And the money, even though it passes through the hands of the beneficiaries, doesn't really stay with them and so forth. We know that HIV infection is a precursor to AIDS. But we know that not everyone, the length of time from being identified with HIV and achieving an outcome of full-blown AIDS is really lengthening. And we know that there are many individuals in HIV studies that are yet to be diagnosed with AIDS. However, the diagnosis of AIDS always includes the condition of HIV infection. So it's almost always or always present, but in and of itself does not lead to the outcome of desire. That's necessity. So we can talk about outcome as a subset of this condition, and we can actually look at the frequency across all of our cases in terms of how often does this occur. Then we're most interested in looking at consistency, the degree to which the relationships among these influencing conditions actually takes place. And when we're talking about the conditions, we're talking about a theory of change, program impact pathways, and we're talking about conditions that are relevant, that we believe are relevant. They make good logical sense, that are relevant to achieving the outcome. And we're talking about such as participation in program activities to build awareness building. So if we're doing community awareness building because we want to change certain behaviors, and we're doing that through educational outreach, if people don't participate in the educational outreach, we won't have any consistency in terms of that participation and its linkage to the outcome. We also have what we call sufficiency, and that's causal complexity, the degree to which a condition is present relative to all of the other conditions. So how often does C occur with A and B? How often do A and B occur together? So we're looking at the sufficiency of that. So there's many solutions that are possible for the outcome in qualitative comparative analysis. So typically when we're using statistical and probabilistic approaches, we're looking at the contribution of independent variables to the change in the dependent variable, our outcome variable. And QCA, we're looking at the configural patterns, many solutions. We're expecting that there will be many solutions. And this really addresses the evaluation complexity that we see in a lot of the evaluation efforts that the UN is engaged in. So essentially, we have, this is just hypothetical, we may be looking at an evaluation that addresses changes in corruption and crime. So the outcome that's desired, obviously, is decreased corruption, and we may quantify that. But we're looking for certain conditions. So we may say that governmental transparency is essential. The enforcement of sanctions is another important condition. And also written procedures in terms of what constitutes corruption. And we may say that these are three very important conditions. They're part of our theory of change. Each one of these, transparency, enforcement of sanctions, and written procedures, is an impact pathway to achieving the decrease in corruption. So we may have one example in our portfolio of efforts to evaluate, and A and B is sufficient to decrease corruption. So just the transparency and enforcement of sanctions is sufficient in terms of decreasing corruption. But we may have another case where we have no reports or very spotty reports of enforcement of sanctions, but we have transparency and written procedures. But we also achieve that outcome of decreased corruption. We can begin to look at the magnitude of that outcome. So in both cases where we have A and B as a condition leading to the outcome and A and C leading to the outcome, we can look and see, is the magnitude in terms of the decrease in corruption the same for both? If it's the same for both, we can say that we have two different configural patterns that led to our outcome. If they're slightly different and we have better, a higher magnitude in terms of decreased corruption with transparency and enforcement of sanctions, we can say that even though we have two pathways that led to decreased corruption, that path one, A plus B, is a pathway that achieves the outcome at a higher magnitude in a certain period of time. So we may want to push, and we can look back at that and say, in the second example, we can say that we want to really focus our evaluation activities and our program activities to increasing the enforcement of sanctions, and that would promote our outcome to a higher degree. So A is the necessary condition for both those pathways. We have two different pathways, but transparency is always part of that pathway. And it's linked to both B and C, but it does not necessarily yield the outcome. So A is absolutely essential, but it's not sufficient. It's only sufficient when it's combined with B and C. So we have different configural sets. So when we're talking about QCA, Qualitative Comparative Analysis, it started with what we call CRISP sets. And any of you that are familiar with Boolean logic, and this is the underpinnings of all of our search engines in terms of Google, when we put in search terms, we're looking, for one, it has this in it, so we may list a lot of search terms, and the search engine discounts, does not include anything that does not have our key terms in it. So that's a very basic example of Boolean logic. So a case is assigned a membership. It either has the outcome or the condition that we're interested in, or it doesn't, 1 and 0. And for a while, CQA was really focused on a dichotomization of our data. But then people argued, well, we're losing a lot of data when we dichotomize. So we started focusing on what we call fuzzy set, qualitative comparative analysis. And we can set up the fuzzy set in any way that we choose. And essentially what we're doing is we're intervalizing the space between 0 and 1. So we may have a fuzzy set that goes from 1 to 0.8, 0.6, 0.4, 0.2, and 0. So 1 is fully in, 0 is fully out, and then we have 0.8 is mostly in, 0.2 is mostly out, and so forth. We can actually do it in terms of a 5-point scale, where we have 1 is fully in and it's 0.75, 0.5, 0.25, and so forth. We can do it in 3s. The establishment of your fuzzy set, the intervalization of that space between either having the outcome or the condition and not having it, needs to be established prior to seeing the data. So that becomes an objective, established fuzzy set. And so if you do it after you see the data, you're going to allow yourself to be challenged. Well, you did it in accordance with the data, and the data drove your decisions rather than objectively establishing your criteria beforehand. What QCA is known for is truth tables. And some of the language and definitions, they're very interesting. Because you see truth tables, and that seems to be a very pejorative term, that anything that's associated with QCA is obviously the truth. That's not the case, but nonetheless they made up the truth tables, which is essentially just a 2-by-2 matrix. The rows are the logical combination of independent variables. They're the inputs, the suspected causes, the impact pathways, the parts of your theory of change that are assumed logically to yield the outcome that's desired. And if we're using the CRISP set, 0 would be does not occur, 1 would be occurs. Each row is assigned an output value in terms of the dependent variable. So we're looking at all of these combinations in relationship in terms of, did the outcome occur? Did corruption decrease? Was stabilization a result of a peacekeeping effort, and so forth? Each row represents multiple cases. It is a summary, and we're going to show you how we get to that summarized truth table. So the combinations of all of these conditions, these independent variables, and I'm using that interchangeably. If you're reading about QCA, you're going to see conditions. If you're doing it statistically, probabilistic statistics, you would see independent variables. It's the same, they're almost synonymous, but you'll see conditions in the QCA literature, independent variables, and the probabilistic literature. So we're looking at combinations, and we're trying to reduce the information as much as possible. This is an example of a CRISP set. And this is actually an adaptation from a study that Reagan did, and he's from Arizona State University. And this was a study that he did from for the IMF. And they wanted to look at whether prior mobilization, community mobilization, severe economic austerity, government corruption, and rapid price increase led to an outcome of community protest. So the community protest is either coded, yes, it happened, or no, it didn't happen. And so you see, this is just taken from his truth table. He actually had, in this particular study, he had 127 cases. So he had a lot of
So each of these cases was a country?
Each of these cases was a country or a country sector. In some large countries, they divided it into sectors. What we're looking for, let me go back, and so we start out with a row. If you have 123 cases, you will have a matrix with 127 different rows. Now, some of those are going to yield the same kind of combination. So you're looking at a combination that can essentially go from 123 across all of the 4 conditions that Reagan was looking at. This is adapted. He had a few more conditions. He had actually 6 conditions that he looked at. But for parsimony's sake, I adapted it to show what it would look like. So what we're doing is we're taking that 14 rows of data and we're collapsing it. So we see that we had 14 different combinations, and we start to summarize and we start to look at what combinations are shared. So we're taking the 14 rows and we're actually summarizing to 7 combinations. And we see that in case 1, it's not repeated in that 14 rows. So it's a unique combination. But then we see that the next combination is actually shared by 4 different countries or country sectors. The next combination in case 3 is another unique combination, and so forth. And we see that some of these combinations actually are associated with community protest, and others are associated, the 0 means that there's no protest. So some of the combinations are associated with protest, and some of the combinations are associated with no protest. And what we're looking at is we're summarizing the data. So he was able to succinctly summarize in the truth table on 123 cases a very parsimonious. And what we're doing is we begin to establish a truth table that looks like this. So we're summarizing it in terms of, we're adding another column. We're adding the number of cases that share this configural combination. So there's 4 combinations that were thought to be linked. And we're producing we have 4 combinations, so we can have 4 by 4 in terms of the number of combinations that are possible. These are candidate combinations. So when we're setting up our QCA, not all of our conditions might lead to being included in the combination. There is the potential that especially if we're evaluating new phenomenon, that we hypothesize that a condition would be a logical pathway, but it may turn out that it is not the case. So we're talking about condition candidates, and we're talking about identifying those conditions. A lot of individuals, if you start out having a number of impact pathways, and I'm saying this, I've been influenced by Deborah Rugg in terms of program impact pathways, but if you have a lot of conditions and so forth, you can start with a cluster analysis to see if any of these conditions really cluster together, and then if they have high cluster estimates and so forth, you can begin to ask yourself, are these really unique conditions? Or are they variations on a theme? Can we pool this data? So the truth table is an opportunity to parsimoniously reduce the variation in your data. We're looking at consistency. Consistency for the first 7 configurations is shown in this table, and we're talking about the extent to which the configuration is associated with the outcome. So we're seeing that down here where we have a consistency of 0, and we see that none of these cases, we have 10 cases, and none of these cases were associated with any protest. So they were not associated. One indicates the outcome of interest. In this case, it was community protest. And we have no consistency in terms of this configuration being shared in terms of producing the outcome of community protest.
So in layman's words, what you're saying here in this particular example is that in situations, countries or sectors where there was government corruption, there was never a protest, even though in some cases there was strong mobilization of the people.
Yes.
So basically corruption in itself does not lead to protest.
Exactly, exactly. And in this case, what we have is we have countries with prior mobilization. And logically, initially, a lot of individuals who were on this study really suspected that prior mobilization would really be a very strong condition or pathway that would lead to protestation.
Right.
And that was not the case. What they found out is that it's prior mobilization in combination with others that led to protest. But by itself, it was not necessary nor sufficient to produce the outcome. So you're beginning to see, I hope, the value of taking qualitative data and summarizing it in a table. And this really goes a long way to satisfy the people who are purely quantitative, who really hold any kind of qualitative efforts, evaluation efforts in with high suspicion and criticism. So we have the example. Let me move my arrow up here. So we're looking for matches, and we're producing this, and there is free software. Here we go. And I have the linkage on a slide that's coming up. QCA has a lot of advantages, and it has some disadvantages. No evaluation tool is perfect. It has to be perfect enough for the evaluation questions that you're answering. And if it's not, no matter how much you like it, it's a tool that should not be used. It's a tool that should be held in your evaluation toolbox for use at another time. So it addresses the challenges of very small n studies. So we may have case
Small
studies.
n, meaning
5 cases,
small
6
sample.
cases, and so forth. So we have a very small sample, but where we make up for that, we know that any of you who are quantitative, we know that an n of 6, a sample of 6, has no statistical power. To conduct statistical probability analyses, even if you do get an outcome, it's likely to be spurious because you don't have the data that will give you a short confidence interval and the likelihood that you have a stable result. But because we're looking at the combination of configural conditions, we increase the number of comparisons. So we may have 6 cases, but we may have 6, 7, or 8 conditions that we're looking at. So we're looking at 8 times 8 conditions. So we have comparisons that all of a sudden go up to 8 times 8, as opposed to looking at what's the difference in terms across 6 cases. So it maximizes the number of comparisons by focusing on the conditions, the program impact pathways. It addresses complexity. Anytime that we're looking at probabilistic statistics, quantitative analysis, we're looking at additivity. We're saying essentially that if we have 6 conditions, that if we add those 6 conditions, we will be able to predict the outcome within a certain sense of certainty, a certain confidence interval. And some of those conditions obviously won't produce significant beta weights in a regression analysis. We're moving away from that additivity in qualitative comparative analysis because we're not assuming that if we take austerity, rising prices, prior mobilization, that if we add all of those together, we'll get community protests. We're saying that it's different configural patterns that yield to community protests. And it's not always the same patterns, it's different combinations. Uniformity is not assumed. So we're moving away from the one-size-fits-all. And we're able to tell a much richer story because we can talk about the consistency of these configural patterns. So they're very prevalent across the cases, but this pattern produces a higher magnitude of community protest than these configural patterns and so forth. So we're looking at, we're moving away from outcome symmetry, and we're assuming that the presence or absence of an outcome may have different explanations. When we do probabilistic statistics and we're looking across a portfolio of countries or a portfolio of programs and so forth, we're assuming that the outcomes are very similar to one another. When we produce a statistic that says that this program is effective to this degree, or the impact is of this magnitude, this effect size, we're assuming that that's shared. And with QCA, one of the strongest advantages is that we can tell the story. Yes, all of these countries, 3 out of 6, had this outcome, but how they arrived at that outcome was very different. And we can support it by the work that we've done in QCA. It's very parsimonious because it's looking at different configural patterns and reducing them. And it's a case-oriented approach. And many of the reports that have been shared by Laura and Deborah Rugg have a case-oriented approach. So it already fits with the case-oriented approach, and it facilitates a form of the counterfactual. And it's a logical analysis of the counterfactual. So when we're talking about moving away from randomized designs, experimental designs, the question that immediately pops up, what about the counterfactual? What would have happened if, in fact, this effort had not taken place? So that is uppermost in the evaluator's mind. So we're going to talk a little bit about addressing the counterfactual. And we're going, how QCA addresses it is it explores plausible counterfactual configurations. So there are a number of cases. You have to have a number of cases to explore conditions. And we're talking about it in geometric space. Anytime we array our data in a matrix, we're talking about geometric space. So if we have 10 conditions, the 10 conditions are a function of 2 to the k power. K is the number of configurations. So if we have 10 conditions, we have the potential of 1,024 different configurations among those 10 conditions. Now the reality is that not every configuration will be yielded in our cases. So we will have many cases that will share configural patterns, and we will have some configural patterns that are not represented by any of the cases in our data. So the cases that are not empirically supported become our counterfactual configurations. They're plausible combinations of conditions. They were not observed in the data. And so we're talking about differentiation of strong versus weak configural patterns. So what we have to do is we have to bring our theory of change to bear. Why didn't these combinations, I mean, if a condition makes it into our qualitative comparative analysis, our QCA, we obviously, it was part of our theory of change. We're not going to just arbitrarily pepper our analysis with a bunch of conditions because we have low-hanging fruit and we are able to collect data. We're only including the conditions that we believe lead to the outcome and are important to measure in our evaluation studies and efforts. So essentially what we're saying is we thought that this was going to happen, but they weren't observed in the data. So we will bring our logical sensibility in terms of trying to understand, to build plausible explanations in terms of why they weren't observed in the data. So we're talking about theoretical consistency. Do any of the combinations that weren't observed in the data, do they have any kind of theoretical consistency? Was there a combination of 2 of the 10 conditions that just never materialized in our data? Is there logical consistency? Each outcome is explained by configurations of conditions, and the outcome was not explained by a certain set of these combinations. And do we have a plausible explanation as to why that occurred? So essentially we're building the counterfactual from a theory, a logical sensibility. because we are engaged in a lot of evaluation efforts, or you are engaged in a lot of evaluation efforts where there is no opportunity for a comparison. So I've done a lot of work in Jordan in terms of community empowerment, and I can tell you that no Bedouin tribe is comparable to another Bedouin tribe. So there's no opportunity to actually identify comparability among Bedouin tribes. And to do so would be to introduce error into the evaluation. We also have, as good as QCA is, and its proponents would argue it is, there are some disadvantages. You need a strong theory to begin with. So if we're evaluating new, novel phenomenon, we need to have some prior causal knowledge in terms of identifying what are the conditions that we should be measuring. It's a small N study, small sample size, and so forth, so we don't produce central tendencies. So if you're doing QCA and people are saying, well, on average, how did all of these countries do, or how did the portfolio of programs do? It's not a question that a QCA truth table will produce. But the reality is that you have a data matrix and you can easily run frequency statistics. So this disadvantage is easily reconciled by the fact that you have data that has been quantified that can be subjected in terms of measures of central tendency. There's an emphasis on dichotomization of data, and people would argue that that's information that is lost. But QCA addressed that by introducing what we call fuzzy sets, and they allow measurement at set intervals. So the data loss can be substantively less if we use a fuzzy set approach. But we have to have coding rules. The minute you move from dichotomization to a fuzzy set, we have to have what constitutes 0.8, what constitutes 0.2, what constitutes 0.6 in terms of community protests. So how big does the protest have to be fully in? And this rubric needs to be established prior to seeing the data so that it is not a reflection of the data you have. It needs to be objective as possible, and it doesn't mean that it can't be tweaked once you do have the data, but the basic bones of the rubric should be as objective as possible. Variable selection bias. If you pick the wrong cases, and this is the anti-QCA people are saying, well, you picked the cases and it produced this truth table and you got what you were looking for. But the reality is that all of our evaluation efforts have this. If you go in and you're doing a community survey and you're not doing a universal survey, you can have bias in terms of the selectivity in terms of who completes the survey. You can have bias in terms of interviews and focus groups in terms of your selection process. So bias is possible with regard to measurement, whether it's in a QCA framework or whether it's in a traditional empirical experimental design, quasi-experimental design, probabilistic statistical model as well. QCA has argued that, well, it's outside mainstream science, and that would be true. Mainstream science is a statistical probability approach. So QCA is not the normative statistical approach, numerical approach. It's gaining traction, primarily because it's novel and it brings more rigor to a qualitative assessment. It does not allow for the time dimension. So as we increase our sophisticated statistical models with hierarchical linear models, uninterrupted growth curves, and so forth, we can introduce time as a covariant very easily. This is more difficult to do in a QCA. However, QCA is really taking all of these criticisms and addressing them. And if in fact you are collecting your data in terms of conditions over the course of time, you can vicariously introduce time that is reflected in when the conditions are measured. So you can introduce a temporal dimension into QCA as well. these are some of the links, and Charles Reagan has his own software. The good thing about Reagan software is it is in fact free. He has manuals, it's easy to download. The only disadvantage and criticism of this software is that if there are Mac users in the audience, you would have to use it in a section of your hard drive that is Windows, on a Windows platform. So it isn't yet there. Reagan also has a website where he has a library of references for QCA. Not only his work, but the work of all of his colleagues and so forth. So it's becoming very, very popular, and it's gaining ground. And as I keep in mind that just because it is a hot tool, there's a proclivity for misuse of this evaluation approach because everybody wants to use the latest thing. The same is true in terms of everybody's focus now is on big data, and that is inherent with challenges and critiques as well. So we're going to stop there and take some questions.
Thank you very much, Anne. Thank you very much. A very interesting presentation, very dense as well. There's lots to digest. I personally understood very little of it. No, just joking. I like it very much. What I like, I mean, from my own personal perspective, is, if I understood correctly, the capacity to distill lessons from a number of case studies, large or small, in a way that, as you said, is not totally subjective. In other words, we do a lot of this in evaluation. We have case studies all over the place. And what we do is we read them and we sort of sleep over them, and in the morning we think that, it seems that this sort of conditions lead to this sort of outcomes. And I'm sure we do a lot of things that the truth table does in a subconscious or you know, fuzzy way. So I'm not saying that this is necessarily bad, but what I see as of value in QCA is that these thought processes are, if you wish, put on a table. Mm-hmm. And so it's transparent, it's more objective, it can be critiqued by others saying, well, you know, you thought that in Peru this was the case, but it doesn't seem to be the case. I mean, there's a degree of transparency, and therefore your thought processes are, you know, in the open for colleagues, for example, to chip in and improve the analysis. Of course, I mean, it doesn't prevent, as you said, the fact that your framework, the sort of causes you are looking for, are going to be the one you measure, and they're going to be the one going into your table, and maybe there are dozens of other factors that you didn't have, you know, in your table because you didn't think of it. I mean, when you were presenting the issue of the protest, I could figure out somebody in the IMF in Washington thinking, you know, okay, so we're going to have to enter the hypothesis that communism leads to protest, but we can't say they're a bunch of damn communists, so we're going to say mobilized communities or something. And I mean, what I'm trying to say is that the even ideological mindset of the people framing the study can, of course, go into the table, because the table is a sort of mental map also of the person drawing the table.
You raise a very important point. An economist would have a very different truth table probably than a political scientist or a sociologist, because an economist would be looking at, you know, variables that really focus on an economic impact pathway, as opposed to somebody who's looking at, a sociologist would be much more aligned in terms of looking at interrelationships of individuals and the relationship of individuals to the organizational structure, the community structure, and so forth. So that has that's a very important point. QCA is the proponents and the people who practice it are calling for transparency. So when you submit a QCA study, the expectation is that you are also submitting an appendix that talks about your rubric in terms of coding and your choice and the rationale for selecting those conditions. And you know, this doesn't make QCA any different, because if you're doing any kind of structural equation modeling, uninterrupted growth curves, more and more peer-reviewed journals are requiring that we not only provide the details of how we ran the analysis, but we provide the syntax as well. So there's a request for a lot of transparency. And QCA can actually be used as a secondary analysis of data. And you can actually use this approach. So if you've taken a purely qualitative approach and you've looked at you know, your inductive reasoning, and you're coding the data in a traditional qualitative approach and so forth, and you're dealing with, you know, iterated reliability and all of this, and you have a very rigorous understanding, there's nothing to stop you from actually looking at the conditions that emerged from that and doing a QCA as a secondary analysis of data once you've collected that information.
Right. But I was willing to ask, you know, given that so much of your own prior hypothesis go into the analysis and into the data collection, did you, in your experience of using QCA, come into presence with cases where you could not reach a plausible explanation of your table? Because, I mean, another thing I like is that the table, it looks like 0 and 1, but if you kind of decrypt it, you know, it's plain, simple language. It's like, you know, corruption doesn't necessarily lead to protest. People can be used to living in a system of corruption, for example. So I like the fact that it can easily translate into plausible explanations that can make sense for people and not only for statisticians. But did you arrive in any of these work at a particular truth table that you couldn't make sense of?
Well, I'm relatively new. I'll be patently honest with all of you, I get bored. So I'm looking for new statistical tools, and I'm always trying to address the methodological challenges of evaluation by looking at tools, and I often find new evaluation tools from business models, from political science. You know, if you're an economist, you're talking about instrumental variables and so forth, but all of these are transferable. So in my use of the QCA approach, I have not found configural combinations of the conditions that I couldn't explain. And that's primarily because a lot of the work that I've done has very strong theory of change. And that is probably you have the highest ability to achieve a combination that you're going to struggle with in terms of explaining with new phenomenon that hasn't been introduced. I would suspect that the UN peacekeeping efforts and evaluating those efforts would lead to some configural combinations that would be challenging, because you know, we're beginning to, how do you collect the data? What are you looking at? Even identifying what the outcome of interest is. Obviously, everyone wants world peace, but that's an outcome of interest that isn't achievable. So we look at, you know, stability. What does stability look like? We look at other areas. So in those ambiguous evaluation environments where the boundaries are blurred, I think that you would probably have the highest opportunity. So I would like to challenge all of you to, if you come up with this and you use this tool, to actually, you know, contact me, because that's where it becomes really interesting in terms of what kind of evaluation tools do you use then.
There's a few questions online that I don't mind if you
Do you want to read them?
Yes, I will. So thank you everyone who's participating online. We've had a few questions come in, and that maybe you can answer. And because we're talking about theory of change, the first one is, can you use QCA to test or strengthen a theory of change? And also, in terms of data collection, Jamie writes, presumably large volumes of narrative data would be read, reread, and tagged in terms of the theme from the theory of change, in order to arrive at the yes, no, or graded rating. And can that be made a participatory way to conduct research?
Mm-hmm. I had actually, that's a brilliant question in terms of the theory of change, and I had never really thought about that. Because when I think of a theory of change, I really think of it not as a static evaluation tool. And oftentimes we develop a theory of change or a logic model, and at the beginning of the project, and we never go back to it. And I always encourage evaluators to use their theory of change or logic models as an evaluation tool in and of itself to test whether the integrity of that model still holds true in the mid-project, at the end of the project, and so forth. And QCA is a really good tool to actually look at the integrity of that theory of change model, and to, especially in the event that Olivier said, you get configural patterns that you don't have a plausible explanation. That's an invitation to go back to your theory of change model and really adapt it. In terms of, if you think that you're going to use QCA, one of the things that you can begin to do is to identify those, and they would already be identified in terms of the program impact pathways in your theory of change model. You will begin to identify those conditions so that as you're coding the data, and when I do coding, I'm biased towards NVivo. I've been using NVivo, used to be Nudist, N-U-D-I-S-T. They're both QRS software products. Nudist is no longer. I've always, chuckled at whether they develop the acronym and wrap the words around it, or they wrap the words to get the acronym. Don't know. But in any event, there's no reason why you couldn't begin to code and tag the conditions for being present as you're coding the data, which would make the QCA a lot more feasible to actually execute, because you could pull that data out in terms of the logical conditions, and then you would be able to reference it back in terms of looking for support. Because in QCA, what you're looking for is you have to build it's logic. And so you have to build a rationale, and you have to expect that people are going to challenge, and they're going to say, okay, provide the data that's going to convince me that that condition was actually present in this particular case. So you can actually do that at the same time.